I'm going to take a look at the K-Silver JS13 joysticks. Now I'm very sure these are the actual JS13 models, as I didn't buy these. They were sent to me by K-Silver, so I don't have a link to where you can buy them. If a link becomes available in the future, I will put it in the description. This is the JS13 model for the DualSense. It has a gray shaft and both sensors are blue. The sensor is held in place by two clips, one on each side. One thing that stands out immediately is the placement of the magnet. It is mounted right in the center of the shaft, and that is very different. Let me see where the poles are. I'm pretty sure the poles are at the small end of the magnet. Yes, definitely. The poles are at the small end of the magnet. So this TMR joystick is completely different from all the other TMR joysticks I've looked at. Let me see if anything else is different on the inside of the joystick mechanism. A tiny bit of grease on the tapered base plate. Now that is the same. Spring isn't held in the pin by a lip, so shouldn't get that click when moved like the Alps. The pin is longer now than what was in the K-Silver Hall joysticks. Inside parts have changed a bit from the K-Silver Hall joystick. Of course, the big difference, the magnet holder, is molded as part of the shaft. That, I feel, is a great idea. That will eliminate any play or misalignment between the shaft and magnet. Magnet holder is molded on both axes, very nice, and a bit of grease where it needs to be. So some big differences in mechanical design. For the sensor, looks like just one part, a small IC. I'll have to pull the PCB out and see if anything is on the backside. But let me see how close to center the TMR chip is. So the chip is mounted a little below the center line. Of course, there's nothing to say that the actual chip part is in the center of the plastic package, but it does look like it will be on the lower side of the magnet. No other parts, just the IC. Looks like XQA on the top line and 3D on the bottom line. It's a very tiny 3-pin package. Back only has some numbers, P01 on the top and 2510 on the bottom line. Let me get it set up to test the sensor response. It can be pretty sensitive, so I've got to position it just right not to saturate the output of the TMR sensor. The yellow trace is the current through my electromagnet and will represent the magnetic field. The green trace is the output from the TMR sensor. It's powered at 1.8 volts. I'm at 10 milliseconds of division here, and the center part of the waveform represents the sensor output, as if moving the joystick from left to right or up to down in about 3 milliseconds. And it looks very good. Now I'm at 1 millisecond division, and the output from the sensor looks great. A very fast response time. All the TMR sensors have been fast, though this one is doing a really good job of tracking the magnetic field. Let me take a look at the signal as if the joystick was being moved from the right to left or down to up position. I'll invert the sensor signal, as it's hard to see how closely it matches the magnetic field signal with them moving in opposite directions. Okay, it's the same in both directions. A very good looking output. Here at 1 millisecond division, it looks great. The TMR sensors are great in this respect. I need a faster electromagnet to give me a better idea of the delay time of these TMR sensors, but I haven't had time to work on that. I did have a little time to think about a better way to measure the delay with what I have. I'm going to go into a bit of detail here, as this is the first time using these readings for the sensor timing. The yellow trace, the electromagnet current, is aligned on the center graticule and represents zero current through the electromagnet. So when the yellow line is on the center graticule, there is no magnetic field coming from the electromagnet. Right now there is 1.8 volts supplied to the TMR sensor. And with no magnetic field, I'll adjust it to align with the center graticule as well, representing what would be the perfect center position. Here's my standard 10 millisecond of division trace with the center part of the waveform, representing the movement of the joystick from up to down, or left to right, depending on the axis. This part of the green trace represents the sensor in the full up position. Then the move from up to down, and it takes about 3 milliseconds for my electromagnet to move from up to down, magnetic field wise. And then this part of the green trace represents the sensor in the full down position. Let me move to 1 millisecond of division. While it takes a little over 3 milliseconds to move the complete up to down range, it only takes a little over 800 microseconds to move from up to the center. So the time difference between the magnetic field crossing 0 and the sensor output crossing 0 should be the delay time. I'm going to move to 10 microseconds of division, and it looks like a yellow and green line, but there is a tiny bit of slope to the line, and one end is below the center line, and the other end is above the center line. I'm going to turn on the cursors to maybe help visualize this a bit better. I'll turn off the sensor trace to help get the magnetic field center positioned aligned with the AX cursor. Then I'll turn back on the sensor trace and try to align the BX cursor on the location the sensor trace crosses the center line. I'm at about 10 microseconds here, extremely fast. Of course, I do need a faster electromagnet, as the slope here is just not enough to get a really accurate reading. But at the same time, I'm pretty confident the delay is somewhere between 5 and 15 microseconds, and that little of a delay, it really doesn't matter. Of course, I did test it with the magnetic field moving in the opposite direction. I figured that would give me twice the slope to work with. But even at twice the slope, it's still pretty hard to tell. To me, this looked like maybe 6 or 7 microseconds. This was the fastest of all the TMR sensors I tested, but the slowest looked to be in the 15 to 17 microsecond range, so really not much difference. Now I've only tested one sensor from each brand, so there could be a few microseconds difference from one sensor to another. But speed is not going to be the differentiating factor in choosing a TMR joystick. They are all fast. Let me see what kind of current the sensor pulls. A little over 200 microamps, like all the other TMR sensors. Moves down with the output at one extreme and moves up at the other extreme, neither of which will be hit when mounted in a controller. So around 210 to 230 microamps, another reason to choose a TMR joystick. Let me get them in a controller and see how they do. I'll speed through the calibration, doing stick center first and then the range, and then saving the changes. Centering is very good for these, almost always returns within one count. Circularity is good. I've come to believe the total percent error is not that big of a deal, as long as it's a pretty balanced circle and the path is outside the circle line. I think most games are expecting the corners to be well over the perfect value, as most of the original joysticks I've tested seem to be in the 8 to 10% error range. Both of these are good, but here, even though the right stick has 0.1% more error, I feel it is a better joystick. It's more balanced. Of course, the amount of pressure applied to the stick can shift it over 1%, but I did try to maintain an even pressure, as close as I could get to how I calibrated it. Now I'll just have to find some time to play some games and see how it feels. These will fit in the DualSense Edge stick module, but the sensor opposite the switch on the joystick has to be altered a bit. The corners of the lower part of the plastic cover have to be trimmed away. Here, I'm using my tip dedicated to plastic on the soldering iron with the iron temp set to 510 degrees Fahrenheit to trim the corners. Need to trim from about the bottom of the KS letters down. I didn't quite get all the plastic out of the alignment holes, so it was a little tight to push in place. I'll put a link in the description to a video on stick module modification to allow calibration. This is a very good joystick. Matter of fact, it may be my new favorite. I do want to get a few more hours of play on them before I make that definitive. At this moment, I think it may be the best all-around joystick you can get. It feels so smooth, and I'm not talking electrically smooth. It physically feels very smooth, and I'm not sure why. I've looked back over the pieces that make up the joystick, and I don't see a reason for it. Tension feels a bit less than an Alps standard joystick, but I'm not sure that the extra bit of smoothness isn't throwing me off here. I love the feel of them. I also like the fact that these were designed to move a magnet. All the previous Hall and TMR joysticks look like a joystick adaptation, not this one. And maybe that is where the smoothness is coming from. The joystick switch has a good solid click to it. This is just a great feeling joystick. Kinda makes sense now why they would send these to me. You have something great and you want to spread the news. Thank you for watching.